Hey guys, and welcome to this video on the two-point form of a linear equation. So let's do this. Alright, so far we've built equations for graphs that are lines when we were given either the slope of the line and the y-intercept, or whatever the dependent variable intercept was. That gave us the slope-intercept form of a linear equation. We've also built equations when we were given the slope of the line and any point on the line. That gave rise to the point-slope form of a linear equation. Now we're going to explore how to find the equation of a line given any 2 points on the line. And here's what our general strategy is going to be. First, use the 2 points to determine the slope of the line. Then, use that slope and either of the 2 points to create a point-slope equation for that line. So let's do an example. Let's find the equation of the line containing the points 2, 3, and 5, 8. So first things first, let's go ahead and draw these on a set of axes so we can actually see them. And in general, it's a good idea to label the points that you draw with their values. Having the coordinates right there will be helpful later when we're doing some calculations. Alright, in this case, let's also call 2, 3 point A and 5, 8 point B. The first thing we want to do is use these two ordered pairs to find the slope of our line. Perhaps you've already counted it out on the graph and have already found the slope. But even so, let's go through how to find it using a few calculations, because later it's going to be a lot harder with crazy ordered pairs and we won't be able to just count it out on our graph. Recall our definition of slope. The slope of a line equals the change in the y values over the change in the x values. So from these 2 points, all we have to do is find the change in the y value and change in the x value, and we're good to go. Let's start by going in the direction from point A to point B. And first, let's start by finding the change in our y values. In order to find the change in some quantity, you take wherever the quantity ended up and subtract where it started from, and you'll find the change in that quantity. In this case, since we're starting at point A and ending at point B, the change in y will be the y-coordinate of point B minus the y-coordinate of point A. So 8 minus 3 equals 5. Next, let's find the change in the x values. Using the same strategy as before, we find that the change in our x value going from point A to point B will be the x-coordinate of point B minus the x-coordinate from point A. So we've got 5 minus 2 equals 3. So we have our change in y and our change in x, so we're ready to find the slope. The slope in this case equals 5 over 3. Now that we have the slope, all we need to do is use that and either of the points to create our equation using the point-slope form of a linear equation. So the two options we have for the equation of our line is y minus 3 equals 5/3 times the quantity of x minus 2, or y minus 8 equals 5/3 times the quantity of x minus 5. Now note, we may be a little concerned that because we have two different equations, maybe they don't mean the same thing. But note, if we put either of them into slope-intercept form by solving for y, we end up with y equals 1/3 plus 5/3 times x. So they're the exact same equation, just written a little bit differently. Alright, so we actually found 3 different equations, all of which will have a graph that's the line containing the points 2, 3, and 5, 8. Awesome. Now note that we absolutely could have gone the other way to find the slope, going from point B to point A. And I'd like to take us through it real quick because it'll be really helpful for later. First, let's start with a change in our y values. In this case, to find the change, we'll take the y-coordinate from A and subtract the y-coordinate from B. So 3 minus 8 equals negative 5. Note, it's clear that the length of this side is 5 units. Of course it's not negative 5 units. But we want to label it with the change in y. It's not the length. That's why we label it with a negative number, because obviously going from point B to point A, the change in our y value was negative. Similarly, to find the change in x, we take the x-coordinate from A and subtract from it the x-coordinate from B. So 2 minus 5 equals negative 3. Of course, the length of this line is not negative 3 units. Negative 3 represents the change in our x values, going from point B to point A. So now that we've got our change in y and our change in x, we're ready to find the slope. The slope equals negative 5 over negative 3. which is of course the same as 5 over 3. And that's why it doesn't matter the direction that we go from point A to point B or point B to point A, we find the exact same slope, and hence we would have found the exact same equation. All right, let's try another one. Now let's find the equation for the line containing the points -7, 6 and 3, 1. Again, first thing we want to do is draw these points on our graph, let's label them with their coordinates, and now let's use these to find the slope. Again, let's call -7, 6 point A and 3, 1 point B. All right, let's start by going from A to B. Of course, we already know that our slope is going to be negative, because if we drew a line from point A to point B, it would slope downwards as we read it from left to right. Okay, let's start with a change in the y values. Of course, going from point A to point B, to find the change in the y values, we're going to do 1 minus 6, which equals -5. So our change in the y values here is going to be -5. Now let's find the change in our x values. Of course, the change in our x values is going to now be 3 minus -7 for a grand total of 10. So our change in the x values is 10. And that makes sense just looking at these points. Of course, going from point A to point B, we've gone down, so our change in y should be negative, but we've also gone to the right, so our change in x should be positive. So we find our slope to be the change in y over the change in x, so -5 over 10, which simplifies to -1/2. So the slope of this line is -1/2. And now we can use that slope and either of these points to go ahead and find our equation in point-slope form. Of course, we could have gone the other way as well. Let's start by finding the change in our y values. The change in our y values will now be 6 minus 1 for a grand total of 5. What about the change in our x values? To find the change in our x values, we're going to do -7 minus 3 for a grand total of -10. Note that this totally makes sense again. And going from point B to point A, we've moved up. So of course our change in y should be positive. But we've also moved left. So of course our change in x should be negative. Now we find that our slope is the change in y over the change in x, which is +5 over -10, which of course again simplifies to -1/2. So in whichever direction we went in, we found the exact same slope. So of course we found the exact same equations. All right, one more example before we generalize. Please find the equation of the line containing the points -105, 58 and -102, 67. Now these points are way off our regular 10 by 10 axes. Now we're going to graph them anyway, and it's going to really help us find the slope and therefore the equation. But I think this example helps show us that we need a general strategy to find the slope of a line just given the two coordinates, even when we can't see them. All right. Anyway, let's label -105, 58 point A and -102, 67 point B. First things first, let's find the slope. All right, let's start by going from point A to point B. So our change in the y values is going to be 67 minus 58, or 9. Our change in the x values is going to be -102 minus -105, which ends up being 3. Now let's always take a second to take a step back and say, does this make sense? Yes. Going from point A to point B, we've definitely moved up. That means our change in y should be positive. And we've definitely moved to the right, so our change in x should also be positive. If you're ever worried if you've made a mistake with your signs, you can also just look at this graph and say, obviously, the slope is going to be positive. If it's not positive for any reason, you know you've made a mistake. All right. So in this case, we find that the slope of our equation is the change in y over the change in x, 9 over 3, also known as just 3. So this time we got a nice integer slope. Now that we've got a slope of 3, we can use that and either of these two ordered pairs to create our equation in point-slope form. Really quickly, let's find the slope in the other direction. All right, now our change in the y values now is going to be 58 minus 67 for a grand total of -9. Of course, the length of this line is not -9. -9 is the change in our y values. The change in our x values will be -105 minus negative 102, or negative 3. Of course, negative 3 is not the length of this line right here. Negative 3 is the change in our x values. So in this case, going in the other direction, we find the slope to be negative 9 over negative 3, also, once again, just 3. So of course, going in either direction, we end up with the same slope, and therefore the same equations. Alright, I think it's time that we find a general strategy that will help us find the slope of a line given just 2 points on the line. So let's have 2 fictitious points, and let's just call them x1, y1, and x2, y2. Now it doesn't matter at all where we put them, so let's put them in the third and fourth quadrants, the seemingly scariest quadrants to do work with because they're negative coordinates everywhere. Alright, so here we go. Going from x1, y1 to x2, y2. If we want to find the slope, we need to find the change in the y values and the change in the x values. Alright, let's start with the change in the y values. If we're going from x1, y1 to x2, y2, in this case, the change in the y values will be y2 minus y1. This is the exact same strategy we've done every single time so far. It's just this time we don't have any specific coordinates. We're working with all variables here. Alright, if we want to find the change in our x coordinates, that's just going to be x2 minus x1. Of course, the exact same strategy we've been doing all along. That means if we want to find the slope of the line containing these 2 points, the slope will be the change in y over the change in x, or y2 minus y1 over x2 minus x1. So now we have a formula. Given 2 points and just their coordinates, we can find the slope of the line containing them. We didn't even have to look at them. We didn't have to count it out on our graph. This is so powerful because just given those coordinates, we can find the slope. Of course, we could have gone in the other direction. And in doing so, we would have found that our slope was y1 minus y2 over x1 minus x2. And just like in all of our previous examples, it didn't matter in which direction you went to find your slope as long as you were consistent with your coordinates. Alright, time to do some practice problems. Let's find the equations of the lines containing the points negative 2, 6 and negative 9, 8, and then the line containing the points 162, negative 81, and 147, negative 61. We're going to do the first one together, and then I'm going to let you try the second one on your own. So one thing I really like to do, even though we know the formula for finding our slope given 2 points, what I like to do is label these points as x1, y1 and x2, y2. There's nothing particularly difficult about using the slope formula, but it's really easy to get mixed up with which is an x value and which is a y value, and wait a second, in what order was I going again? And now that we've gotten these points labeled, it should be a lot easier to find our slope. So, we know that our slope is going to be y2 minus y1 over x2 minus x1. And so all we need to do now is substitute in the appropriate numbers and we'll find the slope no problem. Alright, so we found the slope of our equation to be 2. One note, we've got to be really diligent about all of our negatives. It's very easy to make a mistake when you're subtracting a negative and forgetting that it's a negative number. Be very diligent about all your negative numbers in this case. Of course, if we had done it in the other direction, we would have ended up with the exact same slope. And now that we've got the slope, we can use either one of our ordered pairs to go ahead and put this equation into point-slope form. And of course, if we put either one of these equations in a slope-intercept form, we'd end up with the exact same equation. Alright, so now why don't you take a crack at finding the equation for the line containing the points 162, negative 81, and 147, negative 61. I would say don't worry about putting the equation in the slope-intercept form. If we can get it in point-slope form, that should be good enough. So why don't you pause the video and take care of it, and when you're done, play the video and we'll reconvene. And just for good measure, let's do one more practice problem. Why don't you pause the video and please find the equation in point-slope form of the line containing the points negative 102, 16 and negative 18, 100. And when you're done, please play the video and we'll reconvene. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.